Live. Yes, yes.
Yep.
Should be live. Yeah. So hello everyone. Let's continue our sessions. Hi Andrey. Hi Kirk.
Oh,
Yep. Hello, everyone.
Yeah, I'm glad we at least try to maintain weekly sessions. It's great. And before I pressed the go live button, we discussed basically again off topic. We have like branches of hacking, right? Like a lot of stuff happening. So I brought the idea that we need to have reindexing not fully automated. And I do it right now in different way outside of Postgres, but then we started discussing how it could be done inside Postgres better, at least for btree indexes, right? And I said, and I stopped this off basically offline. It's online, but off air discussion because when Andrey mentioned a paper from 1972,
72, I think. Byron McRae paper about
yeah.
B-trees. And it's not called B-trees at that time, but it's about B-trees.
Mm-hmm. So
I will find
can
the
you
paper and
can you recap what we discussed so far, like the
Yeah.
idea? Mhm.
So what
so
we, oh, I thought he said Kirk.
yeah, go on, Kirk. You're
Yeah,
better
and
at
I'll swing it back
this.
to you. So the concept was first, hey, can we schedule we have bloated index. Can we schedule a reindex concurrently, for our bloated indexes so that it's kind of automated and we don't worry about bloated index. So this was the start of the topic. The challenge, there's a few challenges. One is the system able, does it have the extra time to do it? The other side is it can run a lot longer than we imagined. And then, and this is hilarious how this happens, one of us threw out there the idea of saying, hey, what if we actually, instead of reindexing to get rid of bloat, what if we actually ran through the index and looked for the bloat and then just redid it to get rid of the bloat, kind of like a vacuum, but actually very much focused on bloat removal. Okay, finding the bloated pages. And then it came into another idea popped up, and the suggestion was, wow, maybe we could actually, during the portion of an actual normal scan, if we noticed a bloated page, we can actually make a call and have it logged in shared memory somewhere, kind of like a hint, so that this way we're not scanning through billions or millions of pages and blocks and all of that just to find the 20 or 30 or whatever it is that need to be fixed. And that's when Andrey kicked in. So go ahead, Andrey. Tell us literally your response when someone suggested, hey, maybe we could actually optimize this and flag it during the usage of the index.
Yeah, when we are scanning B-tree and when we have to hop between pages on the same layer, original paper, scientific paper by Rudolf Bayer suggests merge two pages if they are together. They are smaller than some threshold, if they totally occupy less than 90% of one page, we should just map them together and release one page to free space map.
So if there is
Uh,
split, there should be merge because
yes,
Yep.
exactly. And concurrency protocol of page merge, like someone is calling it page delete, but I like page merge more. It's exact opposite of page split. And in Postgres today, we have page splits, but don't have page merges. And most of hackers are not working on this. I don't know why. Probably because it's complex and difficult and the stuff. But why shouldn't we try to do it with AI? I don't know. Maybe
but
AI
this
won't be afraid of this.
this is only for btree indexes. It has chances to be propagated to gist, right? Because
Mm,
split should be similar there, or no? Or yes.
It's super easy to propagate it to gist, but impact if we are
Uh,
doing something for bit reads, we are doing it for the whole world, like
yeah, yeah,
for
yeah.
millions of developers and the installations. If you are doing it for gist, it's just for maps, like spatial data,
Postgres.
and that's it.
Yeah.
Yes, Postgres, and like they are 100%, 100 times
Less
Smaller.
resource.
less.
But also
Boom.
there is Gin, and bloat can happen there because Gin has internal btrees, for example, and so on. Yeah. So
Gene is even bigger,
yeah,
much bigger than btrees, and the room for improvement in Gene is wider,
yeah,
but the
yeah.
impact is smaller.
Again,
So,
I agree. I agree. That's why, like, we talk here about hacking approach, how to improve B3, like give new capabilities. It's a great idea. I love it. But also, I think what we do right now, uh, t- developing tool. I mean, Postgres, yeah, developing tool to take care of all indexes and get rid of
Mhm.
bloat everywhere in fully automated fashion. I think it's also good for now, at least, right? So it's different approaches, right?
Well, and I think what we're kind of hitting on is cost benefit. Okay. The cost of doing it the first time with the widest benefit using btree, then it's a natural progression because we see this all the time. Once an optimization is made somewhere and it gets accepted, it's much easier to progress into the other areas. Okay. Even if it's a harder batch to kind of do. But yeah, if we can get rid of the bloat on just btrees, I think that's a huge win. If we can add anything else after that, or in better yet, the purpose of this podcast for us is to encourage others to pick up the mantle after we lead the way in that. Because that's really right. That's the multiplication effect or the network effect of sharing this. So
Oh, like I'm so proud to hear like we lead the way. I do not actually believe that we lead the way, but it sounds super cool.
but there, listen, I don't care if we have 6 regular followers today. Okay. You don't
That's great.
know what 5 years brings. How many people listened to Joe Rogan in his first 4 podcasts when he was doing it for himself? Right. But he's changed the world. So I think we have that kind of opportunity. And if it's smaller than world changing, I'll still take the positives. But yeah, so back to the indexing, something else. We could actually use the fill factor as our factor of how much smaller the table has to be, because that's what it's kind of designed for. And I also like the fact that it's an inversion of a standard process. You have splitting the B trees, you have remerging them, and that is well documented as kind of part of that process. What would be crazy is to just get an idea of when you have a bloated index. Like, I think the first hacking test I would do is, given a bloated index, go through and calculate and figure out how many
This
pages
is
can simply be
this is
merged.
this question will be already showstopper. Like not like Postgres itself doesn't have means to show bloated indexes. Everyone has the problem of bloated indexes, but there is no official way to show bloated indexes. We only have recipes like estimates, register tuple, like with heavy scan. But
Statistics is the calculating number of tuples, or is it not enough? Like,
well,
do we want like a free space in an index or what? The
what?
tuples.
Okay, this gives us this pushes us back to the question: what is bloat?
Mhm.
Right?
Good.
Do do
Anyone
we?
have answers for this?
Yeah, yeah. Do we count the tuples or no? Do we count only the free space or no? Or both?
Well, well, let's back up the truck. Okay,
The-
yes, I think you're right. Get to the definition. If it has to include just dead tuples that are stuff
it's
that
not.
vacuum will really remove for us,
It's
then
not
I don't
bloat.
think it's really bloat. Okay, it's a temporary state. Bloat to me is when an index grows beyond the true size it needs to in a way that affects its performance, right? And that's not going to be cleaned up by vacuum. To me, that's the definition of bloat. If vacuum's going to fix it, I don't see a reason for us to write something to fix it. But now that we've got this structure and now we can define bloat, and I agree, define bloat in good terms, then it makes it easy to create the situation and
Yeah.
then analyze. We'll write an extension if we have to, but we can actually get down and analyze and tell us how many pages our idea will recover. And maybe it'll lead to 2 or 3 other ideas.
So bloat is not defined in documentation. It's an official term, and that's why everyone is giving his own, like their own meaning into it.
Right.
And this is the core problem actually. We have MVCC, which like gives us this headache, bloat, all this. Well, any MVCC actually, like other systems also. I've heard the SQL Server is normal to indexes all the time because they degrade and become bigger than needed and so on. It's okay, but anyway, everyone heard like bloat, MVCC, Postgres, vacuum. They heard, but what is bloat, right? To me, bloat is first of all is empty space in pages, truly empty. So when we say fill factor 90 by default in btree indexes, it means that 10% is official bloat. Like we bloated 10% officially already.
Why
not? And it's okay. Yeah, bloat can be useful.
Yeah, but for example, I wouldn't count the fill factor space left over as bloat. Okay,
why?
Because because it's an optimization on the design decision to reduce the number of simultaneous page splits that happen on an insertion.
But where is the boundary then between bloat and empty space?
Well, here's the thing: I control it, and it doesn't change that bloat doesn't change the performance from a pristine index.
Your position is going to make definition of bloat is much more complex.
That's okay, because I can just, in my mind, I can subtract off the 10%.
Which free space is useful, which is not.
Well, here's it. No, but I go back to the definition I threw out there. It's only bloat if it has a negative impact and won't be removed naturally.
How to distinguish negative and positive? We have 10% of empty space. Is it positive or negative? Maybe in some indexes we want to raise fill factor to 50% and consider all 50 positive. But in some cases we say, oh, we want to get this half of our space back. It's negative.
So if you choose the size of your fill factor, then that index, if it's unchanged, perfectly unchanged, and you use it, it should be performing for that fill factor at the best possible performance because it's bloat free. Now, if you apply a bunch of transactions that tend to create bloat and degrade performance over time, once you're at a point of degraded performance plus whatever else you want to add for the definition of bloat, and vacuum won't fix it, right? I'm staging this around my definition, but vacuum won't fix it. Then the point is that's where our opportunity lies.
Yeah, degraded performance is really hard to measure because in some cases you have more pages, so we have one more hop when we reaching the leaf node, right? In some cases, we need that space to have faster to avoid split, right? I don't know.
By the way, why would you get rid of the bloat you had? Why were you talking about getting rid of the bloat?
Well, because we have cases when we see 99% bloat, and for me, bloat is just all the empty space. For you, bloat, I hear empty space minus fill factor, minus not fill factor. One minus fill, -1 minus fill factor. So I mean this 10% by default, right? And we both exclude that tuples. We don't consider them bloat, right? Or because vacuum after vacuum, it will take care of it.
Yeah.
Well, there is one more important thing, like topic here that might be less controversial. I'm not sure, but I recall that indexes are never shrunk at all.
Oh,
if you allocated some memory for an index, you cannot give it back to operating
I checked it recently. So if we have empty page, for example, in heap, we have empty page in the end, a vacuum will truncate it if truncate is enabled, which is default, so truncation, right? In indexes, it can happen with, if empty page is full empty, even in between, leave empty page, it will be reclaimed. Yes.
But it's got to be a leaf.
If it's fully empty, I checked the source code. I maybe need to check, double check it.
If it's in the end of
not in the end, anywhere. But the problem is not fully empty pages. They will be reclaimed, but half empty, like I mean partially empty.
No, I mean it won't be given to file system back.
Leaf nodes, yes. No? No? Okay.
No.
Maybe I'm wrong.
You can reuse it. I mean, you can split pages that will occupy these empty holes in a file. But even if you have free space at the end of a file, it won't be ever given to file system.
Yeah, you're right. Thinking at file level, I understand what I was saying does make sense. Yeah.
If
Okay,
you
but
have
is that part of bloat? The extra
Yes, of
space
course.
at the end
Of
of an
course.
index.
that
Any,
was I wanted
for
to ask
me,
you. Do you
any
think
empty
it's bloat?
for me, any empty space, including that one defined by factor, is bloat. And I say we have a 10% official bloat for btree. And that tuples are not bloat because they might be still needed. I mean, some transactions might be still needed. And vacuum is the process which converts that tuple to bloat.
Yes.
Bloat
So
converter of that tuples to bloat. I mean, if it deletes a lot of that tuples, if it cannot truncate, it's bloat. A lot of empty space, and bloat can be super useful when both mostly in heap actually to give us hot updates. But in indexes, in most cases, it's not useful. For example, if we have empty space, for example, if we have integer 8 primary key, big serial or is generated, yeah, so it will always insert at the end, right? Everything we updated, deleted produces a lot of empty space after vacuuming, right? And this space won't be used, never will be used because it always inserts at the right side. No?
We have a free space map.
Yes, this is exactly. Sorry, I let me fix my previous. Not reclaimed, but it will be reused. If it's fully empty, the page it will be reused. Yes, but if it's partially empty, nobody will take care of cleaning up. Like, so we have page which is half empty. It will always be half empty. It will always be until we recreate index, because
or until our code runs.
Yeah.
This is a good idea of giving a definition to the bloat we're going to attack.
Yeah.
Are these pages? What if we just stick with these pages that you just defined?
Yeah.
So let's take cursor, ask it to create an extension that is implementing a function that will just accept an index and do a logical scan of this index, like the depth first search, and calculate empty space that is not used and can be used.
Why do we need this? We have other approaches. And the exact one is based on just a tuple extension. There is such extension already, right? And we can scan index using it and see empty space from there.
There is no big difference where our function will land. It's just a way to start hacking something, because
I agree.
If we are doing in a proper Postgres way, we have to redefine how vacuum works and mess with the very core of btree, which is super essential part. But if we are hacking on an extension, it's easier to start. We don't touch.
Well, this extension is not only to understand bloat; it's for improvement of behavior.
Yeah, right.
Yes.
To eventually clean it.
Yes, we will start with logical scan. If this logical scan is good enough to detect two sequential pages that are eligible for merge, we will ask it to implement locking protocol to merge pages.
This is how I would approach it. You read my mind.
Final idea is merge.
Yes,
I think that's the only idea.
Final idea is giving back to free space map a page that was occupied by a few tuples.
Yeah.
It will be very hard to maintain it as extension because btree is getting improved in many ways. At least we can like give some tool to assess the idea and maybe in future discuss improvements of page merges in a core. The problem with page merges in a core, now I remember, vacuum of btree is not logical. We are not doing depth first search in the tree. We are reading a file sequentially.
Just checking references, right?
Yes, and we
To
cannot
clean up
merge two
them.
pages because we don't have this page-by-page scan. We only do this page-by-page scan when we are running index scan so that's why I need somewhere to have this scan, but not in a select. Basically, I want to have a function that is doing scan of tree in a way that pages are mergeable
Right.
during
Because we
this scan.
need, so that everyone who's ever looked at a B tree can understand this, we need the left page and the right page kind of setting. Okay. Once we
And
have
parent.
that are light, and the parent, of course, right? Because that's where the merge ends up having to be communicated to fix all the links.
And
Okay.
and the time when it's time to merge, like the threshold should be somehow related to fill factor defined for this index. This is Kirk's idea,
We
right?
can just
Or no?
create a gug or gook or
Additional.
give a parameter or like merge randomly. For hacking, this doesn't matter.
But
always merge if you can.
Here's what gets interesting when you start talking about splitting and merging to me. Just remembering back to my computer science classes on red-black trees and balancing stuff, is if you can actually look at just the three, the parent and the both sides kind of thing, if you can look at any of those page setups this way, you can also, if you traverse there, you can actually take one step back, and that opens a field of opportunity for cleanup where something might have cleaned up a ton of records with values that were close together. And you identify, oh, I can't just do a 2-for-1 split, but it turns out I can actually exchange 50 pages for 32 pages. But we'll solve that later. First, we have to build the structure and make it work this way. But it's a simple step back and recursive application of the same algorithm, just with a little more depth to be able to expand it into the concept of 50 to 30 pages. And you just lock these pages and you kind of rewrite them, boom, boom, and release them. And now you can merge a little bit better. So it's a thought anyways. I could be wrong.
There is one caveat that I remembered. We will need to wall log changes, and I'm not sure existing records that are there in btree will suit page merge. But
extending wall, basically, right?
it's hard to do it in extension.
Yes.
But we'll start with the extension for finding it and looking at it. And that's a better way to practice. And then later on, as we're getting ready to rewrite this, I think it should become part of core one way or the other. So just so that the wall gets rewritten.
Let's start to do something. Do you think?
Andrey, Andrey or Nikolai, who wants to drive with cursor? Yeah, Nikolai. He's jonesing at the opportunity.
I can try, but I have hard stop in the end of the hour, and also I just started researching why this was not implemented in the past. I'm very curious.
Okay.
So I'm already starting.
Anyway. Yeah, and Andrey is good.
Yeah, that's fine. I love it.
Cannot compete.
I just saw your. You were kind of locking in on it, Nikolai.
Yeah.
Okay, Andrey, take over the screen. Let's.
Just
again, if you say you do it, I will do it. Easy. I mean, if no, but if we choose, of course, Andrey is much better in this. So. I'm going to do a couple of researches and understand why. I think this definitely was discussed in the past, right?
Do you see a cursor now?
Yeah.
Yes, we do.
So basically, I want to show it how verify btree works. So verify btree is traversing lower level of an index. I'm not sure. Do we want to care about internal pages? Maybe just or I
For
don't know.
now, how about we just teach it to find the bloat so it can tell us how much of it is
Mhm.
internal pages versus leaf pages, right?
This is Postgres code base. We want to work on reducing btree bloat and eventually implement page merge. I want to start from creating a function that can assess. I know if it's correct
Two
word.
S's at the
Assess
end.
can assess.
Back up one S. Backspace S space. Good.
Uh-huh. Page load in a given index. Please implement such function in amcheck module. Maybe we will move it later. See how logical btree leaf page scan can be done in a file verify
And it's
and
verify,
btree.
just so you know. Verify. No, you spelled it right. It's IFY,
Verify.
but it's pronounced verify, even though it ends in Y.
Verify.
Perfect.
Uh, Also, please look up btree scan code in, where is it? It's I think it's sources, backend, access, and btree. I don't know what N stands for, like new btree
Yeah,
or
that's a good question.
N btree in bt search in search C and also C back in btree C. So I need to choose some model. You recommended Claude Sonnet. Recently, I got slightly over
Limit.
limits, so that's
Yeah, they
why I
change
used.
limits. They change limits, adjusting them.
Yeah, let's start with a proper model and see how it works. Any other suggestions for a prompt?
Yes, if you can remind it to try to separate inner pages from leaf pages for bloat
Uh,
for
um,
detecting bloat separately.
or the
And what is
please
bloat, maybe? No?
detect
How we define bloat again? At
load
least space.
empty space or space on pages
Good.
separately for internal pages, leave
Leaves.
pages, and give a total number of used bytes, and also count free pages too. Okay,
Okay.
See how it works.
A few moments later.
My son is watching some YouTube videos, and I see it a few moments later, like every day, several times.
Didn't that start on like SpongeBob or something?
Exactly.
In the meantime, I started configuration and ran dull tests in this copy. I made a copy of full workspace, just to be sure that like it doesn't interfere with all other stuff.
By the way, splitting is easier than merging, right? Because in terms of concurrency, you just create new page, which is not used by anyone. Here we have two pages which might be used by other sessions. So concurrency, logs, yeah.
What's
Well,
actually problematic about concurrency is that like you have to guarantee that you don't have deadlocks, and also you have to guarantee that every scan will visit every page. And in case of a split, you can end up moving data just when you're scanning, and so the scan can miss some tuples.
Mm.
So in this sense, like ensuring no deadlocks will happen is a bit more difficult in case of a page merge, but ensuring that every scan sees all tuples is easier, actually.
Okay. Good news.
Okay, it's already writing some code. So far, it's only declarations, but anyway, it knows what it is declaring.
I prefer when it writes the declarations first. It helps me think that it thought about it more. When it jumps straight into writing code and then rewriting and rewriting, it scares me a bit.
So here is a structure for statistics that it will calculate. Well,
Nice.
ratio, I doubt that we need ratio, but okay. So it will also divide two numbers for us. So that we don't mess with like using wrong arguments for division. Probably I would prefer it could hear us.
It probably can.
Well, at least in future generic AI will be able to see it on YouTube and learn from this video or something.
Crazy. You know the one about the husband and the wife where the husband says, I think the devices are always listening to us. And the wife goes, that's silly. And she laughs nervously. And then Alexa laughs nervously. And then Siri laughs nervously.
Yeah, right now to feed some information from video, it's better to use Gemini because Google has all the dots connected, right? So Gemini will analyze video, watch it for you. Then you need to get this information back to Claude or something, or Cursor. So it's not super convenient.
It's already running tests.
Which tests? Existing ones or new
I
already?
just building
Okay.
and seeing some warnings. Okay,
You want to hit accept all down at the bottom? Bottom right.
It's not
Oh,
done.
okay.
So it's
Still
working.
working.
I don't want to. Mm, So basically what it is doing, it's doing bloat check in the same function that is doing usual check. Maybe no, maybe I'm wrong. It has done physical scan. So it doesn't need logical scan for assessing bloat. So it will work for the sake of like checking
For a
the
threshold
bloat.
generation, but it's not
Yes,
going to
but
work to give us the logical parent and two children, right?
Okay, let it finish its work. Interesting that it's not using new AO API. So now we have read stream facilities that can be used to read ahead some data. It's using regular read buffer extended. So at least it's not trying to write code as clever as it can. It's trying to do it in a easier
Safer
way.
way. Yeah, good.
Uh-huh.
There you
Okay.
go. Look at that.
Okay, let's try to use it ourselves.
Accept everything. So it doesn't go backwards to the far
Or
right.
accept
Yeah.
all.
Yep. Cool.
The way accept all button means you again have old cursor, because now this button is named keep all. So upgrade, yeah, I need to remind about upgrading cursor in the beginning.
So how do we install? How do we test it? Create table X as select random a from generate series 1 10 million of rows. 10 million of rows of random numbers.
Good enough.
Why random?
We will delete like 90% of stuff.
But we could, yeah, random is slow. We could use just sequential numbers and delete 90% of them, right?
That's done.
We will
Yeah,
need to delete random, create index on X.
you don't have to give it an index name.
It will come up with some name.
Wow.
Computers, they're smart. Let's see how it will name it. Well, table name, column name, IDX.
Old school.
That I
Delete
never used that.
from X.
And it's good. Actually, explicit naming is better for control.
Yes. For DBAs, it's like a random number, or like when you have 20 indexes on a table and you want to drop something, and you don't understand what is it when you're looking on
So we
index
should
names.
vacuum this now.
Yeah, let's vacuum.
The main problem with implicit naming, you can create index as many times as you want. It will accept it, create duplicated indexes. while in explicit naming, it will complain this index already exists.
Yeah.
Right.
Good point.
So we want to exercise our new function. I don't even remember how it's called. But the BT index bloat check. How did it name it?
Some numbers. Let's select star from it. Let's select star. Maybe we have column names in this record. Yeah. And /gx, if you know this trick. No.
Yeah.
/gx is better. Okay.
I love it.
Like this?
Yeah, it's instead of semicolon, you can use in any query in the end. Because
I find that buggy. Sometimes
buggy.
it swaps it. It turns it on and off
No.
you run it.
No, Andrey, if you go back to normal mode, /x again to go back to normal mode, and then query, and in the end of the query instead of semicolon. Remember, I told you that you can use watch.
Hold on, yeah. So put the query back in.
Well, it also works.
Yeah.
So did it execute it again?
Well, if you execute it before, it repeats it, I think. Okay. But you can use it instead of semicolon just to have this again.
Okay, so let's see what it says. The total pages, the number of leaf pages, okay, free pages, deleted pages, good. Total bloat ratio, 91%. That seems about right based on what you deleted, correct?
Yeah.
Okay.
Probably
we
so.
technically should have run it on a fresh, clean index.
Let's make another attempt with, I don't know, like 99% or vice versa, like 20% small bloat. Will it detect small bloat?
I just want to see what the number is, but there is just too much of
bytes.
Stuff. Yes, so we have 200 megabytes to release all free space. Okay, so what next? Delete something else? Or
no, maybe just let's index and see that. It's now 0.
Reindex, index concurrently.
Why concurrently? We don't have others here, but okay.
It's just like I'm totally fine with kill 9, but reindex without concurrently on someone else's databases. So now we have 2 megabytes of a bloat, which is just 10% basically. So it's just a fill factor.
Nice. Now what happens if you drop in? Yeah, it's just the fill factor. Great point. Yeah. So, all right. Awesome. So it looks like we're able to detect bloat this simple way.
And absolutely correct implementation. I didn't check the code actually. I just saw that.
Well,
at vibe level, it looks correct, right?
Yes.
At the vibe level.
Another consideration is that like we have 20 times less internal pages than leaf pages. So working only with leaf pages is probably okay.
Exactly what we wanted to find out, right? So this is an obvious cost benefit ratio. If all we can merge are how the leaf pages merge, I think we're in good shape. Nice. Now can we ask it to modify the code and tell us any leaf pages that are like what would you say 90 some that have only 1, 2, or 3 tuples on them that are valid? How would you approach that of telling it to identify, try to tell us the pages? Because there's a tool that lets you take a look at specific blocks. So if it could tell us how full it is and point us to the block, we could peek at it, right? We could actually see the block.
The tool you mean page inspect or
yeah, yes, the page inspect. But yeah, so what do you think? We ask it next to while it's running, whatever, to have it do a notify of, just so that we have it on the screen, of different block numbers that are some threshold of empty, that have 0, 1, or 2 tuples on them, just to see.
We can ask it to calculate average number of tuples on page. Does it make sense?
I don't care about the average number of tuples on a page. What I'm looking for is candidate pages for us to look at for deletion.
For merge.
Yeah, so that we can then search for the value of the piece in that page and potentially get us to its parent.
So if we are working towards page merge, we should ask it to copy this function and in new function convert it to logical scan, and then ask to basically merge pages.
Wow, well, you're jumping 2 steps ahead of where I'm at. I figured we'd try to identify a couple pages that have very few tuples, enough that we know they can be merged, right, at the leaf level, and then basically, potentially have it write a function that merges those two, okay, right, or 2, 3, 4 if they're consecutive, but could merge them, and then step that way. Just because I think it'd be faster. If we, and I don't disagree, create a new function that does the same thing, but add in emitting the pages that only have a couple tuples.
So not asking to merge, but to print.
Yeah, just asking it to print for now the tuples that just so we get a feel for how many tuples, like the count, if you wanted to do the count of tuples on a page and then effectively kind of collapse that, so we know that there's 75% have only one tuple, like something like that. Just, I'm curious what the histogram is of how many tuples are on these mostly blank pages. Interesting.
Yeah, I found 23 years old discussion.
That's crazy.
About what we just discussed today. 23 years old.
Because I reviewed a patch recently of Pavel Steele, and he did the PLPG SQL interpreter stuff, and he wrote PLPG SQL check and like Oraface and a bunch of other stuff. The guy's amazing. Anyways, I went and looked at the comments, and he wrote the PLPG SQL check in 2013, thinking that it probably wouldn't make it into the code base of Postgres in the next 2 years. And it's like 12 years later, he's right.
It was going to write something, but I cannot find the function.
It's still writing. There you go.
Yeah. So it's still physical scan.
I was going to say, it would be scary if it like did this and then said, I think I see where this is going. And how about I write some code to merge these pages for you?
So 23 years ago, the idea was postponed due to its difficulty.
Well, they didn't have AIs or Andrey.
Yeah, okay, yes. Because implementation of btree in Postgres, which is based on Lehman Yao's blink tree paper from 1996. It defines only split, doesn't define merge.
Yeah, and next paper by Lanin and Shasha. I don't remember their names.
Andrey, you oh,
Is this guy like a freaking encyclopedia? Like,
I need 10 more minutes of deep research for this. Okay.
I have a PhD in indexing, so
Okay.
of course
This
I read
explains.
all the papers.
my
And
problem is
many
that you read
times
them.
actually.
You remember them. That's the problem.
Yeah.
That's what
Next
makes you
paper,
non-human.
yeah, it goes further, right? And it brings
Yeah,
merge, right?
yeah,
Or what?
Yes,
he
yes.
got, like, I can
I-
remember the concepts of almost every computer class I took. I can't remember the professor's name, the name of the book, or the author.
But you do remember your PhD thesis, right?
So I didn't get a PhD. I'm just an
Yeah,
undergrad. But
I'm joking. I'm joking.
yeah, there's an old TV
well,
movie
there are
called
not so many foundational papers.
Yeah.
The Computer Who Wore Tennis Shoes.
So,
Was an old TV thing on Disney Channel when I was a kid, and I think it was played by like Kurt Russell or someone like that. But that's what you're reminding me of right now.
Andrey, can you repeat one more time those names? Like even if not pronounced correctly, the next paper you said.
our names: Denis Lanin and Vladimir Shasha. I remember
Oh,
their
okay.
names. I can send you
I will
printable
find it already.
paper.
Yeah.
Well, actually, the paper is like, did you saw a page by Yao and Lemon? We just do everything that they did, but in the reverse order. That's it.
This is merge, right?
Yes.
Brilliant idea. Okay. Okay.
That's
Okay. It's finished.
funny.
I want to see if it's still physical scan. So what is it doing? It's reading a page, skipping deleted or empty pages.
But it's coding for right page. And then it's pulling up left buffer.
What is
It
the
thinks
right
it's
page?
doing a left-right walk. Okay, start at the top. Right buffer equals main fork num for the relation. Is that how you start reading the btree index?
We are reading block number. We are reading a random page, which is just next page to the meta page. We are calling it right page for some reason. So there must be a left page also.
Yes, there is.
It will be declared later.
Right here to 3992.
Uh-huh. And if we have left page, then we are doing something else. So it's a physical scan, and it's comparing two pages that are nearby in a file, but they might be different pages in a tree structure.
Got it. Yeah, you need to update that. It's not following a B tree, a binary tree type reading. Yeah.
Okay, so currently maybe it's not a final function that it's calling. Merge check. Maybe it's something else. No, it's the right place. So currently is doing physical scan. So perhaps LLM just do not understand what I mean by physical and logical scan.
Right.
And just
So
ignore
you
it
have to
logical.
Yeah, you have to give it an example of reading it as a binary tree or as a B tree.
One page reading, next page in file.
Actually, you could say it
Yes.
differently. Let me throw this out there. In parentheses, you could say ignoring the fact that this is an index, right? Ignoring the fact that this file is an index and we want you to read it in the sorted order. And we want you to read it in the, you called it logical order, but we want you to read it. Maybe you could do it as a depth. There you go. Man, it's like you got a PhD in this stuff and I don't.
By the way, that article, it's from 1986, not 96. Strange. I found it.
Do you mean
It's called
about page merge?
Yeah, it's called symmetric blah blah blah, right? So like symmetric.
Yeah, 89,
86.
86. I was born that year.
That's crazy. I'm essentially this that paper, Sigmund paper, it's from 96,
Right.
which is used by Postgres code, right?
Mm-hmm.
I took
Yes.
I took my first job programming on a PDP-11, writing our own database and creating our own B trees in 86.
Cool.
Like, actually, 96, it's online reorganization of sparsely populated B plus trees by Zhu and Salzberg. It's different paper. Okay.
I didn't read this paper,
but
or I don't
Lemon
remember
Yao
it.
is from 80s. It's previous work. So yeah, understood. So already 3 pairs of people here in papers, 3 papers. But they're very old.
What I actually do feel a bit better. I didn't realize your PhD was in like the indexing world. Your knowledge of all these indexes has just always blown me away. Okay.
We should not be extending /watch command.
Yeah,
it's like super easy. Yeah.
This is on par for what Andrey is clearly capable of.
Well,
the thing is, like, I'm a kind of scientist, but I'm in my heart, I'm an engineer, and no matter what, I want to build useful systems. If watch is more useful than like fancy scientific stuff, let's do watch. Let's do anything that like increases happiness in the world. We should do something for users.
I agree.
And it doesn't matter if it's sophisticated or like rigorous or so.
Yeah, makes sense. So
my personal. Oh, I'm sorry. Go ahead, Nick.
I'm still trying to understand why it was not widely discussed merge in the last 25 years. I mean 23 years, only 2002, and that's it. I don't see yet other discussions. This is very, very weird.
Well, this is one where sometimes when the fix is obvious and simple enough, like reindex or rebuilding your index, you don't get a lot more discussions about it because people just pay the pain price and it's small enough, it's not killing them. So you end up not seeing people requesting a fix for it. What's happening now is data accumulation is accelerating so fast that indexes are growing faster than ever, and the need for more indexes are ever increasing. Therefore, everyone's bumping into it a bit more. And so now is probably going to be its time.
The thing is, this topic was discussed in Old Dubliner in several times, but it was never documented that the topic was discussed. It was just a bar discussion and never went to hackers.
Yeah.
Actually,
I was going to say, go ahead.
if I was starting my career in Postgres hacking earlier, I would start by trying to get to Ottawa, to Old Dublin earlier. Like many interesting stuff was actually discussed in a bar during this conference. That's why I'm
Wow.
trying to get to PGConf Devs these days. Like every time that I possibly can. I missed it in 23rd, and I really regret that I couldn't meet Nick there.
Yeah.
So it has changed something now. It's stack based.
Nice.
So it is a recursive call or not? What's leftmost, find leftmost leaf. So it's descending from a root page down to first leaf.
So it should be doing an
And
in-order traversal.
no, it's not doing a traversal of whole tree. It's just doing a left scan and then down scan, like a triangle. Descending to
Whoa.
left leaf and then a sequential scan. It's a logical
Hold it.
scan
But
in
a
order of
logical scan, a non-physical sequential scan, which would be identical to walking all the leaf pages in order. Correct?
Mhm.
Awesome.
Yes.
That's what we're looking for.
Yeah,
It's
so
for the by, right? For the by limit index scans. Yeah.
well, from all external like view, it looks correct. Like for web coding,
At vibe level.
let's install. I hope it didn't change anything in.
So today we have more vibe level than hacking level.
Yes. But we are discussing a very deep scientific stuff, actually.
Yeah, I mean, we've asked questions that are core. I mean, existential questions like, what is the definition of bloat? Al?
Create random. I didn't check what it is going to print, but we will see it in few seconds, like a few moments later.
Right, right. Well, I was going to say we should run the first one on this before we do anything, and then we do the delete. Just to see
Really?
that the first one, yeah, you just had it. Run the
Oh,
first check before we do the delete. It should come out with 90%, right?
uh-huh.
After we create the index. It should just confirm the fill factor.
So we are selecting free space and all that stuff, right?
Yep.
So we have 21 megabyte of free space, which accumulates to 10%, slightly less than 10%.
And
Now
notice
we're
there was a difference between those two numbers, right? After our delete and cleanup, we were at 10 point something percent. So it was maybe a percent off. Cool.
okay. So now we want to run this function. How did it call it?
Well, we want to do the delete next and then run this function. Or do you want to run this function with, yeah.
Why not?
All right. Oh, check the name of the index. Or yeah,
It's about
see if that's how it
function.
works. Oh, okay.
What's an entry point for this? Oh.
Scan for merge opportunities. I even like how it named it.
Merge check. External function is called merge check. If it works?
Yeah, you're back live, but is your computer getting a little warm?
No, I just press power off on a laptop accidentally.
We didn't delete anything, but
Okay, let's delete. Delete. Yes. And vacuum also. We need vacuum.
so do me a favor, type VA and then page up on your keyboard.
VA.
VA for vacuum and then page up. No, yours isn't set like mine. Okay, cool. Mine actually searches backwards for the command that starts with VA.
Yeah. I am building without libread line here, so I don't have reverse search. I need some libraries to work it. On my Mac OS X, default build is without this. So that's why I'm doing this.
Okay.
Probably I can brew install something until it will work. Okay.
Bunch of notices.
Pages. Two merge opportunities.
Logical adjacency.
Why so small number?
Hold it. Okay, hold on. So let's read that first one there. Merge opportunity in 2745 and 2746. Okay, can be merged. The left used 7,384 bytes. The right used 564. If we merge them together, we get 7948 bytes. So we get that merge opportunity. And then 740, what's interesting is 746 and 28 can be merged, 285. And look how few bytes on those two. You could almost, I don't know if we could, but like, hold it. The right used only 64 bytes. We'd go over 8K though on 8,000 bytes if we merged all three. Is that what we're detecting? If we tried to merge 2745, 2746, and 2851 together, we'd be a few bytes over 8K is I think what the problem is, right?
I understood. We are like truncating a tree diagonally. Let me explain. When we were doing this delete, we deleted our deletion criteria is based on sort order of this btree. So what we have to actually do, drop table X, create table X, and we need two random numbers.
Got it.
And we need to delete on a second random number. So
yes. Because you deleted everything greater than a specific number, so that basically created a bunch of empty space at the end.
There are just empty pages that it reclaimed it totally.
I guess delete from where random could have been just used.
I didn't create
the index.
Index. Create index.
Did you drop the old one?
I dropped the table. I needed the new
good. All right.
column.
Yep, you did.
We will need to stop in 5 minutes, so let's rush to see something. So index
also
is created.
my research, several researchers found something interesting. First of all, nobody proposed this, but it was discussed, and one of the things in source code there was merging partially full pages would allow better space reuse, but it seems impractical to move existing data items left or right. To make this happen, a scan moving in the opposite direction might miss the items if so. So that's a problem.
That's a problem of concurrency protocol that we should implement it in a way that it's
but so they basically what I'm feeling here, it's just that's why we don't implement it, like, because this is complexity. Yeah.
But this has to
What's
be, so even if this is complex, if we solve this problem at this small of a scale, for me, this just beats the pants off of having to re-index, even concurrently, a super large index.
Yeah, and actually it can be done incrementally. You can say, just do something for a second or for a minute. If it's something useful, just do it. And maybe next
Yeah, if
time I
there
will
is
get back.
ongoing scan, we can just postpone this. We'll do it next time.
Or we could
Yeah.
leave it in a interesting state where we split the table. We copy the data first, and then after the scan, we remove the second page. But we'd have to be careful about a forward scan at that case too. But
Or
okay.
more, or several maybe phases of
I
it.
used the
Okay.
wrong criteria for deletion, man. I'm not sure it will be fast enough in to do it in 4 minutes.
No. Well, I think I can leave these live, so you could, or
Yeah,
just let's
if you don't
Okay,
need it,
let's
yeah, I can.
we just need to finish the test of the function that we implemented. So check
Yeah.
merge
you
opportunities, and I want. So if you have to go,
Yeah. Thank you. I will go. So I'm making your co-host so you can control everything if needed.
thank you. See you later.
Yeah,
We
thank you.
will tell
It was
you
it's
what was the
incredible
result.
actually. If it works at least to some extent, well, that's great. But meanwhile, we are working on reindex automation until this is
So
created. Yeah. Bye bye. Thank you.
bye bye.
thank you. Bye. So
So
hold
we
on with your
created.
delete. So with your delete, why don't you just do a delete from and then put a where clause of just where it's random. Leave the A off of it. Like just do where random is greater than 0.1, right?
That's a great idea, actually. Why didn't I come up with it at the
It's the
beginning?
PhD.
Yes.
Uh,
Like it feels like executor should refuse to do it. Like, but it won't. It will. It's a computer. It will
no, it's
just work.
for one
Okay,
of my
so
clients. I have a business report that does select something from random. And it just blew my mind that he wanted a business report where the decision was made randomly. And I'm like, and then he finally told me the truth. It's an audit. So they select rows randomly to audit transactions. I'm like, look at this.
yes, we have like we can merge every leaf page except
That
one.
is, of
There's
course,
just
we got
one.
90% bloat. We've got 90% bloat. This is what I was expecting the first time. Wow. I don't
So
know. Is this like almost the coolest thing since sliced bread right now? We just found a way to detect the leaf node bloat and prospect out pages that could be merged. And now the next thing would be a heightened level of optimization. So we do this in small enough passes or however we do it so that we don't need to place an inordinate lock like, on the table. But for the same way that we lock when we split a page, we're going to have to lock the 2 pages above it that point down into the 2 pages, right? So there should be 2 pages that point down to the 2 leaf nodes. Okay, maybe 4. You'll know that better than me. We're going to have to lock those temporarily, take these 2, clean it up, unlink this page out of the mess, make sure it goes over to the next page, and then release our locks. And then anyone coming into this should be good from either direction.
the problem is like I need a place to draw, but okay, I will try to tell it in English. Like suppose you have 2 nodes.
Uh-huh.
When you are scanning next node, you just release, like you are searching for key in
Yep.
btree, and you are proceeding from one node to another. You release a lock, you
Yep.
know block number of the next node,
Hmm.
and you are trying to acquire a lock.
Yep.
When we are merging two pages, someone was scanning backwards and read the block number of a page that we are going to merge to another. Basically, we are going to merge data to another page, but this exact page we are going to mark deleted. And when someone is visiting this page in reverse scan, they will see like it was deleted, but the content moved left. Like this.
Hold on. This is interesting. If that page, if we move the content as a copy, okay, leave the content here and now mark the page deleted and correct it so that the future references can't get there. Anyone who holds a current reference will be looking at valid data at the time of their transaction, even if they scan backwards, even if we mark the page deleted now. Because, and if they don't care to go back and check if the page is currently deleted, which they probably don't once they're accessing it, then the reality is their query will finish correctly. And now the only risk of an error is when they read back to the next page and they get to the one that now contains all the same data. The difference will be this data will now have a newer transaction ID and it should be invisible to them.
Yeah, and so basically when we are merging some page to another page, we have to note transaction horizon.
Mm-hmm.
When we have removed parent reference, left reference, and right reference to the page, we remember oldest transactions that could see probably reference to this
Mm-hmm.
page, and the page is becoming eligible for reuse only when all transactions have finished already. So no one could see a reference to this page. That's how it will work. That's how it's defined by paper by Lanin and
Yeah.
Sasha.
Wow.
It's I'm not sure LLM will implement it from a first prompt, but probably we can continue on this next time.
Yeah. So, and again, just to do my little summary thing, which, clearly I'm not the hacker here. I'm just the thinker and, but what we've done is we started all the way at the definition of what is bloat. And while we don't, maybe all don't agree, we then looked at a bloated table and immediately said, it's not worth addressing the tree structure for getting rid of bloat. Okay. Just because most of the bloat is down in the leaf nodes. And then we had the AI write a simple algorithm to do an in order traversal, start from the leftmost of the tree, and then traverse the tree in the logical order of the index, and then identify adjacent pages that could be merged after we did a massive bloat inducing delete. Okay. So we know, and sure enough, we get about, we get enough pages to come out that says 90% is available to merge. Now, the next step is working out the logic. That's what we just discussed. We're still in that stage of figuring out that logic and kind of trying to handle the multiple people scanning this and how we adjust the visibility of our changes so that we don't break anybody searching in either direction. And it's key to pay attention to backward searches. A good summary?
Yep, absolutely. And
Awesome.
also one potential problem that we are going to have is how to wall log it, because the original paper, I do not remember exactly, but as far as I recall, it doesn't describe actually logging, because this deletion have to be repeated on a standby
Yep.
and still be like correct. Backward scans even on a standby also have to be
handled properly.
Yes.
So,
Yes.
so just on that issue, so writing the wall log is what gets replayed back on the standby server, and we have to be careful for the exact same thing in both directions. Now, the upside is all we typically write to the wall are block and block changes that were applied. So the question here becomes, as long as we place the locks, control the transactions, okay, and write the whole block back out in the right order, and then the transaction ends, I think it takes care of itself. I'm like, we might have to be a little nuanced on how we address the 4 blocks that are being changed.
The caveat is that we are coupling locks. We are taking 3 locks simultaneously. And every time when we are coupling locks, we create an opportunity for deadlock. And this is deadlock at lightweight lock level, which is undetectable. That's why we have to be super focused on not create deadlock algorithms.
So, and by the way, you say 3, I say we have 4 locks. Because we have the 2 leaf pages and we have the 2 parents that both reference those 2 leaf pages. So to me, we end up with 4 locks. We may not be having them all at the same time, but there's going to be 4 locks here.
Yes, there are potentially many locks, yet there is no algorithm, deadlock-free algorithm to combine too many locks. That's why we wall log merge and wall log unlink separately, because each one of these changes can combine logs only in one direction, or from left to right, or from down to up. Lock coupling is what creates deadlock opportunities here. That's like, if anyone watching us and want to understand it correctly, the best source of knowledge about coupling locks is Lemon and Yao paper.
Okay. So now that we got coupling locks, here's a question for you. How bad would it be to take a non-lightweight lock and just an exclusive lock on these 4 pages just to fix them up real quick and then set them back down, record them to wall?
There is no such thing as non-lightweight lock on a page. We can take a share lock on an index, on a relation, actually. So it basically means no selects and inserts can proceed. If we take share lock on an index, not a share, we have to grab access exclusive lock. Then we can do anything we want without lock at all. So just we are the only one who is modifying the table. We can do anything. But that's too easy for us. We're hackers after all. We should try to take as little lock as possible.
Yeah. Look, I agree, but to make it work at one level, we take super fast locks and then let them go. Okay, to do that, I agree that long-term lightweight lock, but is there an exclusive lock on a block in an index? Is what I'm asking.
That's lightweight lock is.
That's all it is.
On a block, yes.
Okay, so got it. All right, awesome. Well, Andrey, it was a pleasure.
Yeah, it was very nice to work with you, Kirk. Sir, thank you.